for manufacturing value chain. Our presenter would be Sashi Sairaman from MTAB Technology Center Private Limited. Sashi has a career mapping across various roles. She has excelled in these transformational assignments in engineering, training and fashion retail companies alike. Her roles are defined through product development, marketing, to manufacturing and consulting, with a stint of running a business in a new domain and managing corporate finance. She has been an integral team member and defined her leadership qualities in each of these roles. She also serves as a vice president of the Perungudi Industrial Estate, part of a team looking to attract, retain, and develop companies and infrastructure at the industrial estate. Sashi captures the attention of her counterparts by positioning ideas into win-win opportunities. Take, for example, the vocational training segment. Almost 4 years ago, she saw the Indian and global need ahead of its time and proposed vocational training projects to her team. Through 2010 to 12, the projects saw rapid implementation in several government vocational training sectors. Where one sees a problem, she has a unique way of seeing and identifying viable business opportunities. As a passionate entrepreneur and a professional with high integrity and a caring mother, is a strong role model of women on how to stand out and succeed in the industry. So I welcome Sashi Sairaman to take this dais.
Thank you for the very nice introduction. Seldom have I received such a good introduction. Kudos to you and your team. I always regret being the last speaker for the day, and when I see the crowd, it's even worse. But I'm going to try to keep this as light and informal and informative. So this is a presentation which has been co-authored with Siemens, for whom I'm an executing partner. As the earlier gentleman, while he introduced me, I am the managing director of a company called MTAB Technology Center, and I will give you more details about it a little later. Since it's been co-authored with Siemens, it's mandatory I make the introduction about Siemens. Siemens is across 8 different verticals. Most of you would know Siemens as an engineering, a process industries, and a drives company. You would also know them as Siemens Gamesa in the area of wind power and renewables. Siemens has a very strong portfolio in digital factory, or the digital enterprise as it's called today. Mobility is another area where they're very strong through their metro trains, the high-speed trains. Power and gas is also a very big area for them. And with all this coming in, energy management is a focus area, and healthcare. For those, they make high-end medical engineering products as well. So that's Siemens to you. What we do. We are a services partner for Siemens and a technology partner. When I mean a services partner, we execute a lot of their digital enterprise solutions, both for education and industry. On the industry, we call it a smart factory, which is nothing but a connected factory. And on the education, we set up centers of excellence. As a technology partner, we also build interactive digital content for them. We have solutions for manufacturing engineering, for robotics and STEM engineering, and as such, we also offer training services. Now coming to my presentation. So when you look at all these 5 different areas, you see the words flexibility, time to market, more product variants, individualized products, and flexibility in design and facility utilization. If any of you have been in the manufacturing side, or any manufacturing, forget engineering, you're talking about food, retail, consumer goods, anywhere, you'll find that these are all the terms that are frequently used. Today, the customer wants highly customized products, individualized products, so your product variants are increasing. Your product life cycle is coming down incredibly. I think about a decade ago, a cell phone was used for at least a year, 18 months. Today, It's a 90-day cycle, if I'm correct. Every 3 to 6 months, there's a new product that's coming out. Flexibility. Product configuration has to be, they would like it to do starting from alpha going up to zeta. So that is the kind of flexibility they want. And considering all of this, from a manufacturing perspective, flexibility in design, flexibility in facility utilization is extremely important. So these are all this thing. Now with this premise, my presentation starts. There are 3 areas in a digital enterprise, or what you call digital engineering, we address it in 3 areas. We talk about digital product, where ideation and product design happens. Digital manufacturing, where the product is realized in terms of manufacturing. And digital performance, where the utilization of the product and the facility is captured to understand or optimize better. Now, what we mean by digital twin is when the entire design, manufacturing, and utilization, an entire virtual representation of these product design and manufacturing process is done, we call it a digital twin. This is what we mean from a manufacturing and an engineering perspective. Now, one of the reasons this is becoming increasingly important is because of the product life cycle coming down. In many cases, digital engineering, my topic is digital engineering. So many cases, if you look at it, digital engineering, it means for most people when you ask about what digital engineering means, the first thing that will come out is design. The next thing is probably process planning. That's the next word. CAE, computer-aided engineering, is now catching up. Supply chain management through ERP, SAP is another thing that comes up. Then you have production planning, which is again coming into it. Automation, these are the common used topics in digital engineering. But today, digital engineering is taking an entirely new meaning. It goes into these 4 buckets as far as we are concerned. We start with design. It goes into planning and manufacturing. Then there is a statutory angle that comes in terms of digitization. And then there is an after-sales support, or what we call utilization and performance management. Let's take the area of design. You guys are highly silent and a very, very thin audience, so I'm a little bit nervous as well. How many of you are from a manufacturing background here? Fantastic. So you would understand that when somebody talks about design, the first thing that will come to mind is a mechanical structural design. It could be, that is the first thing that comes. And most people use CAD. They use very high-end, best-in-class CAD products. And then comes in, most products today are not just mechanical products, they also incorporate electronics in it. So there is an electrical design that comes in, which is also. And then if you are a little bit of more focused in terms of a product design, you also get into, you at least outsource the CAE bit, which is the analysis, the engineering analysis. But today design has gone many milestones beyond it. Gone is the concept of discrete design, where you do mechanical, electrical, everything separate. We are talking about integrated system design, where an entire mechatronics design comes in. Okay, so you've done a mechatronics design. Next, the design engineer cannot no longer throw his hands up in the air and say, my job is done. I have done the design, I have released a bill of materials. Because what a stakeholder is expected to do is, finally, this designed product, is it viable for manufacturing? Can it be manufactured in the existing environment is the second question that comes in. Because if you were to go into a manufacturing environment, every time you go into the NPD, the new product development department, and he comes out with a product, when it goes into manufacturing, the first thing he says is, என்னால் இதெல்லாம் பண்ண முடியாதுப்பா. இதுக்கு வந்து போய் முதல்ல எக்ஸ்ட்ரா கேபெக்ஸ் என்ன செட்டப் பண்ண முடியும், இல்லாட்டி வெளியில் போயிட்டு யாராவது வெண்டாரை படிங்க ப்ரோட்டோடைப்பிங்க்குன்னு வரும். This is what happens. So the design engineer goes to a vendor and goes down, but that has now changed. And especially it is changing in the SME industry, surprisingly not just in the large scale, but in the SME industry. What happens is, step 2 is he sits down and also details out the digital manufacturing process and finds out how much can be done in the existing infrastructure. The third is before he gets into it, that is only towards the end. What he gets into it, he finds out what is the costing has to be done by the design engineer today. He has to do what you call built within a certain cost. So that is part of digital engineering. The next thing that is coming into place is if you're especially supplying into the auto or the aero industry or the defense industry, verification, and we're talking verification from a safety angle. There are so many safety standards, so you can't just put in a part which is going to fail. So here, rather than building a prototype and testing it for so many hours, which anyways effectively does happen, you're also expected to test through simulation, through physical, we call it physical simulation, virtual simulation. Once this happens, we're talking about if it is an assembled product, a mechatronics product. An example would be, there is a very high-end machine tool manufacturer called Comau Systems. Now the guy, let me just move it to the next slide, this will help you better. If you were to look at this Comau Systems, what they make is they make machines, they make machining lines, comprehensive mechatronic systems. Every product that comes out, every product that is manufactured takes 6 to 9 months. This is a case study. Now, at the end of 9 months, for him to manufacture and then decide that these are all the corrections that he has to make in every part is not possible. What happens is the minute you go into re-engineering or correction, the product quality starts dropping. So how they do an integrated system approach, a simple example is given is, rather than building the system first on top, what is built is a virtual system, and it is virtually commissioned for not just an analysis on engineering, but on performance, on how it should work. Is it delivering the end result? This is what digital engineering in design is. So we are not talking about for him to deliver a bill of materials and costing and a product, part drawings, but we are talking about an entire virtual commissioning. So this is if it's a design company, but most companies are not design companies. They do design, they do manufacturing, and they also end up selling and servicing. So the next part that comes into it is digital twin in manufacturing. Now, digital twin in manufacturing, in fact, is the highest growth areas across the world. Everybody is now implementing it, and you may have heard of it in various aspects. The ERPs and the SAPs have become a norm in most SME industries, and of course large industries is there. But that's only one little part of the whole thing. The manufacturing engineering systems are only one part of the whole life cycle there. What we are talking about is 3 aspects in this. There is a manufacturing process model, there is a production facility model, and there is a production facility automation model. When we talk about a manufacturing process model is how is this product going to be made? That is what is being discussed. When we are talking about a facility, a production facility model is a full digital representation of the production and assembly facilities, including the manpower, your test beds, and everything that needs to be made. And third is automation. Today, in many areas, automations are coming in, but rather than straight away investing in automation, again, a digital virtual simulation on how automation is going to come in and optimize your entire production. Now, what happens in this case is it allows you to virtually simulate, allows the design engineer and the entire team to virtually simulate and understand how this is. It helps them know that should they go for an augmented facility, an additional line, can they reconfigure the existing line is what they understand and optimize. Now, there are different types of production facilities. For those who have been in manufacturing, they will realize that there are production facilities which produces a standard complex part. That is one basket. The other is where there is different variants available. It is built for a large level of assembly, but then there are different variants available. The third is everything is made to order or engineered to order is what it is. And the fourth is modular reconfigurable factories. Now, any of these factories, this is how the 4 baskets are generally categorized for any production. Now, any of these factories will require, the first thing that they require when we talk about digital engineering, what we do is, we tell them that you need to simulate your entire plant. When you simulate your entire plant, what we get is we get to find out how is it currently working. Given the current production thing, how is it working? Where are your bottlenecks? How can we unlock your bottlenecks? So this is what happens in a digital plant simulation. We develop the entire virtual models of these production systems. We optimize the layout, we optimize the process flow, and instead of directly starting any production or changing, we try to understand what is exactly happening. The second thing that happens after this is an engineering BOM, or for those who understand, is a manufacturing BOM is released, and that entire process is again simulated to understand how it works. You bring in then supply chain vendors, your supply chain kicks in, it connects to your existing MES if you have one, and then it tells you that how your entire process is going to work. Now once this is done, where we come back is we come into process optimization. Whether we start checking whether the actual process is correct. We go into process optimization, we find out whether this is where your more bottlenecks are found out. What happens is you decide on which is your critical, most people who understand class A, class B, class C, which needs to come in, which has to be stocked up, which needs to be reduced, is looked at not from a spreadsheet perspective, but more from a virtual simulation, where you get data which tells you very clearly that this is where you are going to get stuck up and not be able to deliver. Moving on to the next thing is, then you will definitely have people coming in and saying, we need to automate this line. We need to increase automation, we need to add robots, we need to add AGVs, or it could be conveyors and so on and so forth. And in most cases what happens is, maybe in a large industry they're able to go back and tell the vendor saying that I need you to simulate, I need you to show me the whole thing. But in the case of an SME industry, what happens is most of the time the decision is not taken in a structural manner. I do not want to use any other word but that. So what we talk about a structural manner is we take this we take the entire setup and we incorporate automation into it to showcase how it makes a difference. In some cases, or in most cases, automation makes a difference, but there are going to be results where automation would not be an ideal solution. And this is where your entire digital, when we talk about digital engineering and manufacturing, we also incorporate and show this. So finally, what happens is we are talking about a digital twin in manufacturing where your entire factory runs. And you see your entire, digitally you see the product being manufactured and delivered. So you have this, but what difference does it make? Now imagine a scenario where you're right now making a particular product and you need to start making another variant. Now instead of adding a line, what it enables a production, a shop floor person to do, or one of the production engineers to do, is to find out if the process can be reconfigured and rerouted. And this is where the digital twin is very much helpful, because it enables him to take decision about adding a new product or producing a variant within weeks rather than months. In most cases, if you are having a very structured manufacturing environment, to add a new product takes anywhere from 6 to 9 months. Those who've been working in the regular engineering industry. So here we are reducing that time to weeks and ensuring that you're able to either do it with minimal addenda. The second thing it also allows you to do is, in case there is an increase in production, which very regularly happens in the those working in the auto industry, there is suddenly a peak requirement. How do you manage your peaks? So if there is and especially if you're in the SME sector, you do not have a 6-month to a 9-month look ahead. You are probably informed the month before by your OEM saying that next month production has to be 2 times. This is what, figure out, and they start saying add a machine and things like that. Here it enables you to look at how you can increase, plan, and what can be delivered optimally it can be increased, because every production system also has, operates only at sub 60% efficiency today. I should have put in this slide. So these are the 4 areas. What we talk about is existing simulation. The top right is an existing simulation of a setup. In case you're setting up an entirely new factory, how it can be done. If you're augmenting a facility, what can be done. And even if you're having manpower and all of that, manual process, how it can be tracked and programmed. How many of you understand a lot of digitalization in service from a manufacturing perspective, purely from a manufacturing perspective? What we talk about digital engineering and services here, as one of them said, is one of our best case studies which was implemented in my earlier organization. My earlier organization is also part of my family business, and we run a machine tool company, and we have close to about 15,000 installations across the world, with about 8,000 in India and the rest in about 24 countries. All of them being products, hardware products. So you can imagine, and this has been a data across, we're pulling out data for the past 15 years. Now, one of the major things that I did was, we had a very, run-of-the-mill, typical service process that was done, which we went digital. What we did was, every service was recorded first through a system. We had a system which went in one of the software where we logged it in. We also programmed, this is where I think a lot of intelligence came in, was we also programmed for us to give us feedback to let us know which is the problem that is constantly recurring, point number one, which is the product that is giving us the maximum problem, and which kind of customers are also giving us problems. Let's not discount the last one. So what happened is, when we did this, we reconfigured our entire support. We realized that we cannot be running to the customer for every single complaint. So we started having what you call, and we are a hardcore engineering firm, we started what we have called a telecall support, where and we realized that 60% of our problems were not just solved through telecall, which means our ability to react to and solve an issue came down significantly. The second one, what we did is, we started capturing videos and offering them videos to solve an issue. The third most important thing is, the guys who were out of the warranty, you got to pay for the service. We could put it down. And then we realized, within a period of 18 months, our revenue in the service department went 10 times. And service is a revenue that most SMEs have never looked at it. They're all product oriented, and they try to take out most of their profitability from product sales. They never look at service sales. Service sales is one thing that truly is your savior during troubled times. So this is one of the very interesting areas. Finally, this one, we call it the Industry 4.0 Smart Factory. A smart factory is, this is the crown jewel for us, where we have implemented it in many places, and we are considered the resident experts in Siemens for the same. We call it a connected factory, wherein there is a digital twin for design, there's a digital twin for production, and there's a digital performance twin. Here, when we talk about digital performance twin, we ensure that every equipment that goes into that factory is connected with feedback. And MindSphere, as it says on the left side, is the platform on which it will be connected. So here we track production data of the equipment, we track performance of the equipment, we talk about downtime, we talk about efficiency on which it is managing, on which it is operating. And the third most important thing is, we also started tracking in terms of predictive maintenance. It was earlier only preventive maintenance and corrective maintenance, but overall we were able to program and do this. Now this is extremely important. Why is this important? Most of you will know is, today what we are talking, in fact the other company that we work with, they no longer talk about what their equipment will do. They talk about the amount of production it will deliver. So here what the world is changing in terms of engineering is, this particular equipment will deliver so many components for you within 3 years. And when that sort of a data is coming in, what happens is, it becomes a very easy thing for the customer to calculate his cost in terms of a per component. And that is how sales are. Sales are changing. The sale of a hardware or a capex is changing from a CapEx model to an OpEx model. So coming back to this, what digital twin helps is helps us become flexible, as rightly said, reduce time to market, reduce cost, improve quality, and most importantly, improve productivity in all segments of the organization. Thank you.
Something to do with the academy. The basics of engineering are changing, right? So what one has to learn in the colleges is not what we used to learn 10, 15 years before. The knowledge on these tools, should that also become part of the curriculum in the colleges? Or any steps on that front? Because, I mean, people coming at basics doesn't make any sense.
Yes. And that's precisely why we're also involved in setting up centers of excellence along with Siemens to enable people to think on those lines. Because I think gone are the days, when I studied, there were logarithmic tables. I think they're no longer applicable.
Yeah, exactly.
There used to be encyclopedia, it's Google now. So similarly, we also tell the students that yes, the digital twin is extremely important. And we do enable them on those levels. We have about 72 such centers.
Sorry, I have a related question. This is one thing which I keep asking people many times. I'm from the IT side, not from manufacturing, but then I also provide solutions to other industries. When I ask about such things, it should be the technologies and the tools that the students should learn and all that. I'm being told that different organizations have got different styles of operation, which means, for example, TVS could have its own style, Siemens its own style. So bringing a common standard of knowledge is a tough thing, people tell me. Is that true?
No. If you were to look at, I'm talking about digital enterprises offered by PLM, product lifecycle management companies, and Siemens and its competitors work on this pretty much the same platform and premise. The way a design tool works is going to remain the same across the entire industry. Now, how it is going to be used in the customer side, the end user side may change. So as TVS is somebody who would use the design tool.
So implementation can change. The concept is the same.
Yes. What we also stress about is the importance of process knowledge. See, most of the time people also come with a lot of knowledge on tools. But what is even more important is the engineering that goes behind the tool.
True. Interesting.
The digital twins.
Thank you.
Yes, sir.
The digital manufacturing twin and digital product twin is something one could easily conceive. But I think digital performance twin, I think, would be the more complex out of the three, right? Because you don't really, how do you really evaluate the performance of the product or simulate it, or maybe, but of course that you said you would base it on the feedback which would come and then you try and simulate its performance. So what would be your...
From the digital performance twin is actually extremely active in the consumer industry. Today, I think the morning session was by Amazon. If you look at it, Amazon has one of the best digital performance
twins.
Not from that. What we talk about performance is when you go to an Amazon app, it automatically remembers what we've been searching for before. And that is what is there in the consumer industry. Fortunately, or as we are limited, engineering is a very, very smaller industry. The manufacturing industry is a much, much smaller industry vis-a-vis this. And it is only now, as I was telling my friend earlier, that we're just crawling towards that. So today we are only looking at digitizing performance and production data. We're not even getting into, the level of AI. That's why we're not calling it artificial intelligence. We're just calling it digital engineering.
Digital engineering.
Yes, that gentleman had a question.
It is very interesting, to see that there is a complete virtual concept from design, and then from alpha to zeta, and then whatnot, including the performance side. So the complete virtual tour you have demonstrated. But when it comes to the reality, the product in terms of the actual design and the actual manufacturing and the actual performance, how correlated it is in terms of what are the challenges when they see the product in reality, the manufacturing stage?
Okay, I will tell you internally in my company. I think the biggest challenge has always been people. It is getting every stakeholder to accept, participate, and implement. Some people are very enthusiastic, and some people have to be arm twisted and threatened to implement. It is always the carrot and the stick. We do not know which one to use, because that is always the digital, the biggest challenge. For example, the minute you put in, I'll tell you the best example is when I put in the entire digitization of service in my company, my service manager felt I was after his job. He said that, oh no, in 1 year's time she's going to throw me out of the company. I will become redundant. It required a lot of convincing, a lot of encouraging, and a lot of support. So companies, yes, there is a lot of roadblocks that you will hit, but one thing that it can be made a reality. It takes a lot of patience. This is not something, when we talk about creating the entire digital twin, it is normally an 18 months to a 3 years project. It cannot be done overnight, because we are talking about every department, every part of the company to convert and become that way. It takes a lot of, it took me 18 months to go live in my own firm.
Okay.
Where I had a lot of control, and that's why I say 3 years anywhere else.
Okay. Yeah, thank you.
Hi. It was a real good session. I just have a question. So you were explaining about the digital twin on the entire manufacturing process, starting from the design till the product gets out of the factory. But my question is, like, when a product is out of the factory, in your experience, have you implemented a digital twin for a product that goes out of the factory? And based on the feedback from the product, have that impacted your revenue or improvements? Can you share that experience?
I thought I did in the service bit. So I did. So what happens is the minute it goes out, we track the entire history of the product as long as it is alive, till at least it is sold to the next person, because there's always second-hand sales that happens. So we do, and the results have been phenomenal, where I explained that the service revenue grows immensely. Not only that, your design, your entire design of a product could change based on that feedback. Because when there's a constant service issue that's coming in, you realize either there is a vendor issue, or there is an engineering issue, or there is a user issue. If it is an engineering issue, it's tackled through manufacturing and through design. If it is a vendor issue, you tackle it differently. And if it is a user issue, you cannot correct your users. That's never the approach. You understand why the user is using it in a particular way and redesign the entire product to suit that. Sure. Thank you.
Okay, fine. Thank you. Let's start the voting process, please. So please check your voting pads. Answer the. The final one. Thank you. I would request Mr. Govindraju from MRF to present the memento to our speaker.